Hey everybody, it's Mr. Mott. What I want to do is go through a limiting reactant problem, the type that sometimes can get students tripped up here. So we've got our balanced equation at the top, and then the problem states if we have 5 moles of C3H8 and it reacts with 20 moles of O2, what is the limiting reactant? There's a few different ways of approaching this, and I'll try to show you those ways. But what can trip students up is that it's not actually asking for to identify how much product is made, but that is one way that you can go about solving this. Okay, so for instance, if we choose to solve for CO2, we'll do that from both of our reactants. So we would set up our equation here using our dimensional analysis process, and we would solve for CO2. Now, it doesn't specify grams or moles because it's not actually asking for a product here. So the easiest thing is just to solve for moles. All right. And so I'm going to have moles of C3H8 on the bottom, so those units cancel, and moles of CO2 on top. And we'll plug in our numbers from the equation. So I see for CO2 I've got 3. And then for C3H8, there's just a nothing in front, so it means that we have a 1. And so that means that we can make 15 moles of CO2. Now, we would then do the same thing solving for CO2 with our oxygen. Okay, so we're going to solve for the same product in here. So if we're going to solve for this in the same way that we did when we learned about s'mores and limiting reactants, we need to solve for the same product. So moles of O2 on the bottom to cancel, and moles of CO2 on the top. And then we're going to fill in our numbers from the equation. Again, for CO2 we have 3, and for O2 in this case we have 5. So we're going to go 20 times 3 in the numerator, so 60. 60 divided by 5 should give us 12. All right? And so when we evaluate how much, which of these is going to give us the smaller amount of product. So the smaller amount of product is what would be made, but again, that's not what's being asked. It's asking us a limiting reactant here. So because the smaller amount of product is made from the O2, we're going to identify oxygen as the limiting reactant. Okay? Now, that's one way of solving this. And what we would find, hopefully, is that if we, and we'll show you this, if we had solved for water from each of our reactants, the smaller amount of water would also be made from the oxygen, and that's what we're going to solve for next. All right? So I'm going to just copy this and scroll down here, and we'll do the same thing for solving for water here. Okay? So if we have, again, 5 moles of C3H8, we're going to solve for moles of water. Okay. Moles of C3H8 on the bottom, so our units cancel, and then moles of water on the top. Okay, grabbing our numbers from the equation, for water it's a 4, and for C3H8 it's a 1. All right, so we can make 20 moles of water from the C3H8, and now what we're going to do is solve for from our moles of oxygen, how many moles of water can we make? All right, so moles of O2 on the bottom, moles of H2O on the top. All right, plug in our numbers from the equation again, and for oxygen, it's a 5. Okay, so for our bottom equation, we have 20 times 4, which is 80, divided by 5 would give us 16. Okay, so what we see again here is that the smaller amount of product is coming from the oxygen, and so again, that's how we would identify the oxygen as the limiting reactant, because it produces the smaller amount of product. But we have to have the same product when we compare them, because oftentimes if you're going to have a different mole ratio like we see here, and because the mole ratio is different, we have to We can't compare like moles of H2O to moles of CO2 or vice versa here, okay? So those are two of the main ways that we would solve for our limiting reactant and identifying it. The other way is that we could compare reactants to each other. And this is the way that our world of chemistry approaches it. We're going to compare these two and say how much product do we need or how much of one reactant do we need compared to the other, okay? So I'll copy again my problem, okay? Copy that problem, and then we'll try this a third way. All right. So now what we're going to do is we're going to compare reactants to each other. So we're going to say, let's say, for instance, if I have 5 moles of C3H8, how many moles of O2 would we need? Okay. And so let's go ahead and do that there. Moles of C3H8 on the bottom, and then moles of O2 on the top. And again, grabbing our numbers from the equation, for every 5 moles of O2, we need 1 mole of C3H8. And so we have 5 times 5, which is 25 moles of O2. So when we solve the problem like this, what we're saying is that I need 25 moles of O2, and then we're going to compare that to what we have. Well, we need more than we have, and because we have less than what we need, then that identifies oxygen as the limiting reactant. So I would say, writing this out, I would say O2 is limiting because we need 25 moles, but only have 20 moles of O2. And that would be our reason there. If we had done this and we ended up with a value of less than 20, less than what we have, then O2 would have been excess. Now, it just so happened I solved it this way. What if we had solved it the other way? Now, you'd only really need to do one of these if you understand what the calculation means. If we had gone the other way, let's go ahead and try that, just so that we see the difference there and how and what it would look like. So if we said, what if we had 20 moles of O2, and we're going to solve for moles of C3H8. So if we had solved it this way, all right, moles of O2 on the bottom to cancel, moles of C3H8 on the top, from our equation, for every 1 mole of C3H8, we need 5 moles of O2. And canceling out our units, and we're going to take 20 divided by 5. We're going to get 4 moles of C3H8. So what we do is then we say, okay, this is how many moles of C3H8 we need to completely react with our oxygen. And we say, okay, well, if I need 4, how much do I have? If I need 4 and I have 5, well, I have excess. I have more than I need. I have 5 and I only needed 4. So that tells us that the C3H8 would be in excess. And therefore, if this is in excess, if the C3H8 is in excess, then again, that tells us that oxygen is limiting. And so if your problem only asks you to identify the limiting reactant, you have options in how you solve them. Sometimes it's more efficient to solve for product like we did in the beginning. But if you just want to know and identify the limiting reactant, this process can actually save you a little bit of time as long as we understand what the calculation is telling us.